All right. I think that the countdown has completed. I'm hoping that everybody is gently making their way into this session. I will try to talk a little bit to the ether as best as I can and give you a little bit of a welcome. My name is Dr. Jonathan Kuhl, and I am the chair of the Standing Committee for Antarctic Data Management under SCAR. And we're looking to talk to you today about improving the fairness of Antarctic data, strategies, tools, and future directions. And I should probably give you a little bit of an introduction to SCADM, our committee. We work on all aspects of Antarctic data management, trying to bring together the various national Antarctic data centers to try and work through how can we work together, better deliver Antarctic data in sort of a global cohesive way. And you're going to hear a little bit about today about FAIR data. For those of you who haven't come across the term before, FAIR stands for Findable, Accessible, Interoperable, and Reusable. And this is becoming a bit of a catchphrase for finding really better ways of delivering Antarctic information. And so these are some of the things that we talk about as part of SCADM. If you're interested in these sorts of issues, we would welcome you to join in and participate. You can probably get a hold of me, and I'll actually write out my email address in the Zoom chat so that people will have it. And there we go. So today we have a number of different speakers from various parts all around. I'll be probably leading the charge, but we also have Ria Oliver from South Africa. We have Mr. Sami from India, Pip Cohen, also with the Southern Ocean Observing System, and Frank Nietzsche from the US. I am absolutely certain that I've forgotten somebody, but we will make sure that we give them all of the recognition that they need. Anyways, I think that what we will probably do is get set to, Anton van de Putte from Belgium. He'll be talking to us about biodiversity as well. I knew I was missing someone. So it's a little bit awkward for me to start broadcasting to the ether, but I'll probably start myself. Again, I'm Dr. Jonathan Kuhl. I'm representing, although you wouldn't get it from the accent, I'm representing the Australian Antarctic Data Center. And let me see if I can do a little bit of a screen share here. There we go. And I'm hoping that's all good. Yes. And what I'd like to do is talk to you a little bit about what we are up to here in the Australian Antarctic Data Center, and in particular, some of the ways that we're working to try and make data more fair. And a big part of that is that we've been working a lot with cloud technologies in order to do better jobs of sharing our data. But first of all, let me go, yep. First of all, just a little bit about the AADC. Our purpose is to really curate and deliver Australia's Antarctic information as a national Antarctic data center. And some of our principles are very much in line with the delivery of scientific information. We want the delivery of our information to have transparency, and that means good documentation and open source code. We want it to be defensible, having good quality assurance and quality control through review. We want repeatability by having well-defined processes. And also, as we'll come to hear, we're interested in delivering that fair data, making sure that our information is findable, accessible, interoperable, and reusable. And so in order to deliver our information well, we're really starting to confront a need for scalability. Some of our estimated data volumes are going to start to be on the order of 20 to 150 terabytes per voyage, with about 3 to 4 voyages per year from our new icebreakers. So this data really starts to add up over time. layer on top of that unknown requirements for science projects. And we also need to be able to be responsive with our storage and compute to make sure that that data is kept available and available for our researchers to use. So we've been starting to turn towards using what's called S3. S3 stands for Simple Storage Service and has been popularized by Amazon. And it's a way of storing objects in the cloud. It was developed by Amazon, but the API is open source. And so you have companies like Microsoft and Google having very compatible services. And a little bit like HTTP, the files are available as URL endpoints, but you can access them programmatically. And one of the nice things about it is that these files can be accessible not only programmatically, but as a distributed file system. And we originally tried working with commercial cloud, and we ran into a couple of catches. We were prepared for data egress costs. Egress means charges associated with downloading it, but we had a large number of small files, which meant that we ran into some transfer charges. And you might be able to zip that up, but it just became a little bit hard for us to deal with. And so we began to wonder, well, how can we actually manage these costs while providing unrestricted access as is required under the Antarctic Treaty? And so we started wondering, well, can we provide S3-like capability using our own infrastructure? And so we started working with a program called Minio, which actually does exactly that. It allows us to present our file systems that we have on all of our infrastructure, just like it's S3. And so we got that to work. We set it up as a web browser. And so all of a sudden, all of our collection is now available using this S3 type framework. And we said, okay, well, that's looking pretty good. We have that scalability that we were after. And so we started to interface it with our metadata delivery system, got it working. And so we then were able to begin sort of without being too much fuss, we were able to transparently serve the information from S3 as both downloads and then also through browsing. But the nice thing about this is that, as I said, they're now online and accessible programmatically. We can have strong security controls through roles, and access can be managed using key pairs. But what it really does is it gives us the ability to perform some pretty high powerful analytics on our collections without really needing to change our architecture too much. So we've been working with a program called Apache Spark. Those of you who might be familiar with data science would probably have heard about Spark. We can provide, it gives us a way of doing scalable compute across multiple machines. That allows us to scale out our compute and also read distributed data. And so, as I said before, we get our S3, which is our distributed file, and scalable compute, which gives us some really high-powered ways of analyzing our data. And it's pretty versatile in terms of working with languages. We can use Python, R, Java, Scala, and also run SQL-like commands, including spatial operations for those of you who work with GIS. And for those of you who haven't heard of Spark, well, I can also assure you it's being used by some pretty high-powered players. In particular, Netflix is using it as the base of its recommendation engine, and the Deep Space Network is using it to process massive amounts of information. Anyways, it's a very powerful package. And so for us, what this means for us is that we can work with very large file trees of bathymetry, CTD data, and it can in fact even be in raw file format, and we can stitch it together, load it up directly from the S3 bucket, turn it into a table, and run SQL commands on it, so it becomes a little bit indistinguishable from working with it like a database. So we can actually take these files and treat them like they're a database table and begin working with it in things like notebooks, generating histograms, whatever it is that you want to do. Anyways, a lot of flexibility, a lot of power, a lot of scalability, which is what we want when trying to deliver our data a little bit better. The other nice thing is that this then sets the stage for bringing in machine learning. Spark has its own machine learning library, but it also works with programs like TensorFlow, scikit-learn, or Keras. So if people wanted to do, for instance, image recognition or climate data mining, this is all possible, and it's facilitated by having this sort of underpinning architecture which allows us to use these big data tools. Now, so far I've made it sound pretty good, but it's with great power there comes great responsibilities, because you start seeing a whole lot of potential inconsistencies in your file. So, you know, it's actually good because it begins letting you see where these are and getting really down in deep with the data to understand what you actually have. Definitely naming and structure become a lot more important. And in this case, our public data become truly public. What you see in our file systems is what the clients get. Also, exposing our collections security through obscurity is not a good defense anymore. So what you have to do is you have to be very aware of what you're writing with in terms of what people are permitted to use. Writing policies can be complicated, but it is extremely worth it. And you get a lot of peace of mind with locking your data systems down properly. And so this is also helping us to develop cradle to grave data pipelines for our new ship. And so we're working to help build this into a larger pipeline. And so just to summarize some of what we've been working on, we have been making a lot of progress, but there's still a lot to do. This is new field for us. It's a new field for everybody that I've been talking with. Minio has helped us push forward to using hybrid cloud type architecture. So being able to work with our on-prem systems, but just as easily be able to move into using more commercial systems. We do have an honestly working proof of concept for processing distributed data at scale. Now what we need to do is really use it in anger and try and go operational with it. And so we are also ready to begin experiments with applying machine learning on our data. The key will be sort of thinking how we can apply that most productively. And so what we are looking to do is to improve the fairness of our AADC and SCAR data. And so this is the first steps at it. Okay. So I think that's probably it for me for now. I do see some questions coming through, and I'll try and answer them as best as I can. But yes, if you have questions, please feel free to write them into the platform, and I'll try and get at it. Anyways, the first question that I see is, how is this platform different in comparison to the ECMWF archive? Does it offer copyrights to the data contributor? I am not as familiar with the architecture of the ECMWF architecture. However, the way that we tend to handle copyrights is that working in the Australian Antarctic Data Center, things are usually given to us as a curator. A lot of what we work with are owned by the Commonwealth of Australia. And then we do absolutely provide authorship accreditation. In terms of ownership, I think that if it weren't owned by the Commonwealth, I'm not sure how many data sets that we have that are of that nature, but I think that you could probably use a similar architecture in other repositories and handle it that way. I'm not sure if that really answers it, but yeah, we try and make sure that we have clear attribution, at least within the AADC, of who is the owner versus who is the custodian versus who is the author. And where will the data be shared? Do we have a website? Absolutely we do. And so how you get to it is through our normal AADC website, which is data.aad.gov.au. I'll put that into the chat later, but you would be able to access it through there and our normal data search services. Okay. I think that's probably, let me go back. Sorry, my mouse is just a little bit angry at the moment. There we go. Okay, Are there any other questions? I don't see anything. Okay, so then what I'll probably do, there we go, chat. Okay, yep, we're all good. Is there going to be an effort to standardize the data? I think that what we would probably try to do, at least with what we're doing, is to develop appropriate readers. And so we would standardize through reading as opposed to on the data itself, but standardize the metadata. That would be my recommendation, but I might also be a little bit of a heretic in that, so I'll probably leave that there. And the last question that I'm going to do is, how do you think must be the way to share information with others, platforms outside? I'm not sure what STA is. So I think but to answer, the best way that I think of doing that is having standard services, things like the OGC compliant web services. SQL is kind of a de facto standard as well, but I think that standard web services and well-documented web APIs is probably the way that I would recommend to go. Okay. All right, I'd better stop babbling and I better move on, and I'll turn it over to Ria.
Hi, thanks, Jonathan. I hope everybody can hear me. I will mute my video so you won't be seeing me because it's got a bit of a bandwidth problem here, but I'll start sharing my screen. Somebody else is still sharing. Jonathan, I think you're still sharing. Ah, there we go. Oh no, this is not right. Oh gosh. Ah, there we go. I hope you get a clear picture and that the bandwidth is not too bad for everybody. Okay, I'm going to talk about the importance of FAIR principles of data management in the humanities and social sciences, and probably everybody wants to know why am I talking about it. I have sort of the portfolio within SCADM to look after humanities and social sciences. I shall focus a little bit of background for you, bit of big data, digitization, mostly focus on FAIR principles, highlight the SCAR policy specifically. Then, if there's time, we will go and quickly go through a few examples. My examples will come from the Antarctic Legacy of South Africa repository housed at the Stellenbosch University. So why do we have to talk? We've got Antarctica and we know there's a lot of data, as you just saw, that terabytes, hectic terabytes of data that is available in the science. But there's also humans involved in Antarctica. And what do we do about the data regarding the humanities? So data protection is there. And this is where this comes in, is that we make humans information available to the rest of the community and to the outside world, out of the Antarctic community, with data, and even the science communication that we do these days, outreach, and that's all data with the humanities specifically. So just go do a bit of background is where this digital humanity started. I'm not going to stop here long. There is an international organization, HDHO. You can check that on their website. They support, give advice. And then different countries got also associations in this regard. And South Africa also got the association Digital Humanities of South Africa. It's to promote and understanding the practice of digital approaches. And this is very good if you are in the social sciences and humanities to check if your country got an association like this, because you can collaborate and learn from each other. And it's a close-knit community with started within the library and information science discipline. So also the interest, these different interest groups, this one is that's mostly relevant to us, it's audiovisual data and digital humanities. They're exchanging knowledge, expertise. If you don't know how to preserve your visual material, this is exactly the way to go. And especially nowadays, as we know, we've got now a virtual conference, all these videos and recordings all need to be preserved. Then They also have resources like journals, book series, conference papers. So please visit their website and see what they have in store that you can use all the while. So just quickly on big data and the humanities, I don't want to stop here very long, but this is a very good source if you want to learn more about it and apply it into your field. So it covers aspects such as navigating the abundance of information that is in the humanities. Therefore, big data represents the output of a world that is more and more digitized. Indeed, as digital technologies occupy a more and more central role in the working and everyday human life, individual realities are increasingly communicated through digital objects, which are progressively replacing physical objects, even shaping new forms of virtual reality, as this conference. And from the use of social media and digital devices for communication and knowledge sharing, human life is progressively being digitized. And this is so important that we have to digitize the humans that are involved in Antarctic science. Our current situation of an online conference depicts this digitization, and the internet made it possible. Increasing digital transformation coupled with technology evolution make computer computations and digital humanities so much more important in reality. So the focusing of the arts and the humanities on big data needs to be investigated, especially in the Antarctic environment. So with the previous background, I will quickly try and take you a tour through the FAIR principles. I think this is most of you that in data would know all these. So just to carry on. So we first got to go to Findable. Data must be uniquely identified, easy to find and described with rich metadata. Metadata is the first action to take to make data findable. It is also important that this metadata must be registered or indexed in a researchable source. This seems to be an easy one, but regular assessment of metadata is necessary to ensure user X and quality of metadata, even if it's just an Excel sheet that you use to index your data, and important that it must be standardized, keeping up to date with the international standards. The Alpha repository on DSpace, as I previously said, and our institution keeps up to date regarding new developments in metadata. Metadata are registered, indexed in a searchable source. It needs to be easy for users to find information. They need to know what the repository covered. And in the following slides, I will quickly show you how it's working on the Alpha archive. So this is the Antarctic Legacy of South Africa archive, and I will quickly run through it. So we've got how to, contents. I'll go those two slides I will show you. So this is the make things more findable. Person come to this page or to this website and they say, oh, I want to get something, but I don't know where to go. So it's a how to and a content that we'll look into. But you can just search through the whole repository. You can search, browse through different communities and collections. So if you don't know you want something on Marion Island, as you will see there, the second one from the left, you just go to Marion Island. But if you want to look at photos all over of meteorologists, you can just go to the photo gallery. You can even go by create date and specify a time frame so that I just want photo in the photo gallery or just Marion Island from a certain period. Authors is also contributors, is that if I want to see images or material donated by Hannes Legrand's family, I will go to authors and type in Hannes Legrand and see what I find there. You can even do it from titles. It's also important that if you've got a repository that has got a website, make it user-friendly so that it's not just like a dead thing there and they don't know, but that they realize it is a visual thing. There is footage, there's artifacts, but not all is displayed on this. So that is why on contents that you've previously seen, you've got to sort of describe what is available. It's like the Antarctic Bulletin. There's maps available. Repositories like National Archives are in there. 360 footage. Angelo gave a presentation regarding this, and we are now going to put 360 footage images on it. You can also see her video on the SCAR online virtual display. Artifacts is on there, interviews, so that people can see what can they look for. And important in the social sciences is you've got to decide, what am I going to carry in my repository? What is my field of expertise? And then the photo gallery. Describe what is in there. Is it just photos of the Israel Palace, or is it of Sinai? Will I find photos of the architecture of Sinai base? So these things are very, very important in seeing that what can I find on the archive. It must be really easy for a user to find this. This is a section that's also in the how to, and you can see there's navigate through the Antarctic Legacy Archive. Go to our archive, it's www.antarcticlegacy.org /archive, or just click on archive. But this is also a way to tell people, get contributors to tell us, oh, but this is incorrect, or I've got a better photo of this, or I've got better quality information, or this is a way to let people know they can still contribute towards the repository. It's important that we get a lot of slides. We sometimes get it anonymously and we don't know everything. So rather than to let it go lost and not be able to preserve it, we scan it and we put the metadata that we are able to identify on it. But if somebody else can go on there, we just got somebody of Marion Island, Kenneth Cockjoy's I think granddaughter came across it, and she said, oh, but I know some of the people, I know some of the photos. And now that collection of Kenneth Cockjoy will be much more in detail described. So that's why you need to tell people this is a repository, but it's an ongoing, it's alive, and it's not just a repository there that you go into and never ever update it. So this is very important to do this. Okay, the one, accessibility. That's probably the most difficult one, because people want to keep their data to themselves. They want to keep information to themselves. Luckily, overwintering teams of South Africa wants to actually tell everybody about it. So they send us their diaries and letters and correspondence and photos. So we've got all that. The Answer repository has in its early years for registered users only, but since 2015 it's been open access. That means the data and the repository can retrieve via different measures previously discussed. But it's also known that the metadata, as you can see on the right-hand side, can tell it what is the right. There is still copyright on the images. There is still people that you've got to acknowledge when you are using the photos. You've got to acknowledge the Antarctic legacy. You've got, for instance, acknowledge Hannes Lagrange if he's using some of the photos that he's taken on the Trans-Antarctic expedition. So all these metadata are there, but there are also different protocols, and they're right at the top. And I'll quickly go through a few of them, or actually I'll prove them all. So the first one is the Berlin Declaration of Budapest. It's making everything free available. As you can see, that started in 2003, and regularly on an annual basis, this is updated. So the sign that you see there is the unlock one, and that's the one that you saw probably on Jonathan's slide as well. So unlock information for everybody. The Antarctic Treaty System says scientific observations and results from the articles shall be exchanged and made freely available. And that has not been retracted, so it's still standing there. But SCAR realized that they've also got a data policy. I know we've worked a lot on this now, the SCADM committee, but got this exception is that it's full, free and open access, but where human subjects are involved, confidentiality must be protected. Where data release may cause harm and where specific aspects of the data may need to keep protected. So that is very, very important to take into account of accessibility. You can make these things accessible, but you must make sure what you can really exchange freely and put on the public internet as such. So most of our documents are freely and open access, but the whole archive or the whole repository is protected by a copyright statement. But each single item is as well protected by the statement. And then there's consent forms, like for instance, if you want to use this in a publication that you're going to make a profit out of, you need also the consent of the person whose material it is. But in this image release form, people donated their material to the archive and to the repository of South Africa. So there is two ways that you can still make material that people don't want to sort of open on the public internet, make available, and you make it a private item. Like most of our interviews and a few images is private items, but you will still be able to see that it is there. You won't see the real product, or you won't see the real information or the real image, but you can then contact the administrator of the repository and they can make it available for you when necessary. Then there is another thing in embargo items, and that specifically in the science world is very a thing that is coming across a lot, because we know it, we're working with scientific information, and in certain circumstances that cannot be made available before publishing our findings. And this option allows a contributor to put an embargo on the information for a specific time period, and then you can make it for a month, you can make it for years. Still, the data that you want published can be made available. Therefore, it's very important to discuss this with your contributors and ensure data is protected but still be made available when deemed necessary. Now, if we come to the I, it's interoperable. It's sometimes a difficult one to know what is interoperable. Interoperable is actually, can I, as a user, make use of the material, or can I just see it on the computer, or must I make a print screen? And then it's not that good quality. How can I download the whole document? So it is important that you indicate the language that you are using. Must be an international language that you are sharing it. You must use ISO standards, like that the Marian Island is a coverage that, it's a spatial coverage. How are you using it? Standardized keywords, and use keywords within disciplines. There is a lot of set of keywords, especially in the humanities and social sciences. Library of Congress is one of the big ones that you can use in this regard. So I'm quickly going to show you a few of the examples on the Antarctic legacy of South Africa. So we've got images, and they are all in JPEG format. At first, we started with very small files, but these days we can accommodate bigger files. We do keep bigger files in backups if people ever want better one for, say, for publication or use for other purposes. We've got presentations in PDF format and some as well in a PowerPoint that can be downloaded. We've got videos. You will see their videos in MP4 format. You can see Ansha's video that will be on the YouTube as well, and later on our archive after the conference. And down below is an interview video that is also available, and that's in MP4 format. Then this year with the pandemic, we realized that we give a module, we're part of a module in the BSc in the science faculty, and the students can't go visit the library. They can't go take out books and study them. So we've done a few books, and specifically on the Marian Island, Prince Edward Island, and Gough Island are now available in PDF format on the archive, so that the students can make use of it. So there's audios in MP format, free formats, there's interview transcriptions in PDF format, documents in PDF format, diaries in PDF format, newsletters. There's a lot of material. Go and have a look. I think what's very important that if the format that you choose to run on your repository, that make an entry, that an entry in your repository, it's necessary to know. It doesn't help you have a format that can't be read by anybody else. So there is several formats available that the repository needs to choose it from. And it's also very important that these formats available must play a role in this regard. So reusable. If we come to reusable, it is that metadata are to be released with a data usage license. And that is in the archive and all, as Jonathan mentioned, in their archives as well. So metadata meet the main relevant community standard in the case of SCAR. My role in SCADM is specifically to help people set up social sciences and humanities databases or repositories, and to let national programs know that they can contact SCADM for help and advice and support. Last year, I was able to hold a workshop on data management in social sciences and humanities during the SHAS conference in Ushuaia, organized by Christian Lorenzo. 17 social scientists attended the workshop, and I still get sporadically feedback from these attendees. It's not necessary to use a platform such as DSpace or Figshare. Even an ordinary spreadsheet, such as Excel, can be made. But the main thing is preserve it and keep FAIR principles in your mind. So I just want to highlight again the role of SCADAM is to promote long-term preservation and accessibility of data relating to Antarctica and the Southern Ocean as sustainable repositories, to assist in establishing Arctic data management policies, priorities, and best practices, and FAIR principle as a practice resort under this. So please visit the SCADAM page, and if you go to scar.org and just click on SCADAM, you will be able to visit it. As humanities and social sciences, we've got to get more involved. If we look at there's the master directory and there's the National Antarctic Data Center that you can go and have a look at. But when you go to the Antarctic Master Directory, I think there's 2 data sets on human dimensions in the whole Antarctic Master Directory. So we as social scientists and historians and in the field of humanities need to do more in this regard. So humanities and social sciences data, why do I give this talk? Even the most brilliant scientific discovery is of little value. As Cornelia Lydekker said, is that the early researchers did not think that at one time what they were doing will become history and need to be preserved for future research and future generations. Destruction of heritage, I always like to say that it's the attack on the history of mankind. And if you go to the bullet number 3, after a conflict, and I can think we can put here after a pandemic, heritage can be a starting point for rebuilding a common identity, a common Antarctic identity. So just quickly, where do I fit in? Alpha fits in within the South African National Antarctic Program, and it is funded by that. And we fit in under human enterprise, and specifically in the data management. So I quickly want to show you, just take one person, if time is still allowed. Jonathan, just stop me if need be. This is Martin Bester. A lot of people know the slide. I use it time and time again. It's very easy for me to use it. He was 40 years, more plus 40 years now, devoted to science. He's a human. He was a sealer. He was a friend, a mentor, a scientist, a cat hunter. People enjoyed him. He inspired people. They write about them in newsletters. Even a book was published by Nico de Bruin and Chris Tyson that capture the influence that Martin Bester had in the lives of a lot of people. But Martin Bester, if you see that little picture of him, was sitting in our office, scanning his slides and adding metadata to it so that it can be preserved and preserved in the correct way. We will add keywords towards it, but he gave us the dates and the people that are in these slides. And then till time, this is a photo of M71. I will quickly go through this. I think my time is up. And you can see here the metadata. The coverage spatial is Marion Island. Date created, it was 2014. You will see in the description of the abstract is all the positions that they had on the team. If you go to subject, you will see Marion Island team photo, team member, and then specifically Marion 71. But if we add actually meteorologists as a subject or diesel mechanics, then later on you would be able to retrieve all the diesel mechanics that were just at Marion Island or at Sanai, or all of them within Sanai. So your metadata is an ongoing live thing that you must update it regularly. The second one is a image by Tom McCherry. And if you go there, we've got another spatial metadata, and that's Kuto Bay. And we would like to add at one stage the longitudes and latitudes of these things. And then you will be able to see how many photos is being taken at Kuto Bay for a matter. So I think my time is gone. So I hope you enjoyed it. And please contact me if there's anything you need to know. And just lastly, Antarctica's got SCAR, and the humanities, we've got shares. So in getting data there, make use of SCADAM and contact us to do this. I just like to thank the NRF making it for me being possible of SCAR and SCADAM specifically, and thank you for SCAR Online, SCAR, SCADAM, and shares making this possible.
All right, thank you very much, Ria. That was great. If anybody has questions, please feel free to start sending them through. I do see that a couple have come through. And so one question that I see at the top that we have for you, Ria, is what practical interventions can incentivize and promote best practice and embed fair principles amongst the research community?
Okay, I'm not sure if I understand correctly, but you want to know what's a big practice to get incentive for people to contribute, or just incentives for people to make use the FAIR principle. So the one on contributions, that's not easy. There was a lot of talks and that, but you've got to target people specifically to donate, to contribute to your archive. You also got to sit down with people and go through their data to make sure they are using the correct keywords, that the correct metadata is added to the material that you add to your archive. I'm not sure if that answers your question.
I hope so. I think that that's what's there. If it didn't, then people can add more. I guess another question for you. This seems to be more for the group, but you're catching it. Do people proactively come to SCADM for advice as much as you would like?
I think I'm in sort of a lucky position within the social sciences and humanities specifically, as people do contact me within that group. I'm not sure within the other groups, and I think, speaking out of the South Africa point of view, I think countries can contact SCADM easily because we more easily, because we can actually learn a lot from other countries. And why do we have to invent the wheel again if it's already working in another place? We don't have to reinvent data management. The principles are already there. We don't have to reinvent FAIR principles, but application of it within a certain country. I think that is what's very important for the whole Antarctic.
Okay, great. And just sort of for me to add to that as well, we're always interested in having people who want to know more about data contacting us. SCADM does have a webpage. Please don't be shy. Just go ahead and email us, and we'll try to answer as best as we can. Sammy from India.
Yeah.
And here we go. So Mr. Sammy, are you sharing your screen?
Yeah, I'm going to share it.
Okay, fantastic. We look forward to hearing from you.
Is it visible? Is it, I hope.
Yep, you're all good.
Yeah. Okay. So good evening to all of you. I'm B. Saktivel Swami from National Center for Polar Ocean Research in India. See, today I'm going to talk about how Antarctica meteorological data from Indian station, we have made a database for that, along with some of the applications of machine learning techniques, which I'm presently working on that kind of area. Just I want to talk about it. So I will not be talking about FAIR of Antarctica data, but I'm going to talk about particularly how we made Antarctica meteorological data center. Just I want to talk about it. See, when John Tuner, I mean, he is one of the meteorologists, he is working with the British Antarctica Survey. He is one of our research advisory committee member who came to India 2 times. Still, he is one of the member. So he advised me to, why don't develop Antarctica Meteorological Data Center, I mean data portal, like he has developed Met Reader. So that is as a sponsored project from SCORE. So he advised me, then we said, okay, I will do it. So based on that idea, we conceived this kind of development, we want to do that. When he visited next time, I saw him, he was very happy to see that portal. I mean, the similar kind of things. In Antarctica, we have 2 stations. One is Maitri, another one is Bharati, and Gangotri is buried into ice, as of you know that. So what we are getting, I mean, meteorological data from online data from Antarctica, which has come to my FTP server, that is called data server. From there, I'm bringing it to this portal. So if you look at this portal, we have about the project and data availability, metadata, AWS data, that is called automatic weather station data, and surface station data, and charts and online plots, as well as we are providing 24 hours temperature data also we are providing it. So whatever the data is available in the portal, it is publicly available. People can access it. The main objective of this, we want to archive the data. Whatever the data we are receiving it, we want to archive it in a very systematic manner. So we have a different kind of stakeholder within our country, like India Meteorological Department is there, Indian Institute of Geomagnetism is there, and as well as one of the defense lab. They are also getting the data from Antarctica, and we are collecting the data from there. And whatever the data comes in that, we are archiving it. And the main goal is we want to identify the nature of the phenomena. Is there any kind of phenomena exist or not? At the same time, we want to do some kind of research work on that. Whether the data has any kind of prediction, our pattern exists. If the pattern exists, can we go for the weather prediction, weather forecasting? Not only that, we want to do for similar kind of things, blizzard prediction also for our station operation. So during the winter, blizzard time, what are the operation, what are the scientific, what are the logistic operation can be performed. So that is what we are trying to do that. So these are the data is available. Particularly if you're looking at weather and environment data, we categorically made it station wise, what are the duration available. This data is made available in the form of CSV as well as NetCDF format. Anybody wants to download CSV file, you can download it, as well as NetCDF file. So it is easy. Based on their whatever the requirement, they can do kind of computation, whatever things they can do it. And we have advanced big data. Whatever the data is received from other stakeholders, we have placed here. Particularly the station also you mentioned which station we have, what is the duration. Again, what is the format? The data is huge, which cannot be shared through web. So we ask them to request us, and we will send through the FTP. So those kind of things. And particularly mooring data, we have recently launched mooring in Arctic. So the data is collected last 2014, 15, 16, 17. Data is available. It is already placed in the portal. This, those who are really interested, they can download the NetCDF file. They can do some kind of their own academic and research work. So, and another important point is that we want to provide the data parameter wise, temperature, air pressure, wind speed, and things individually parameters. What is the percentage of availability? The accuracy of the data we want to provide it. This basically the concept is given by Dr. John Tuner. So if you look at the next slide, if I have it here inside the bracket, if it's January 0, that means there is no data. Average of this. If you look at 2015. January is no data. If you look at February, there is a average data is that the percentage is 65% we have the data. Remaining time due to some logger problem, something else, we couldn't collect the data properly. So that is the reason we mentioned here the percentage of data availability is with us. If you look at as of now, we have to the 2020 July, we have it. Because of there is satellite communication problem, we are not receiving the data from Bharati station since July 16th. So the data is available 34%. So this data is available public, and this data is being used by Mr. Steve from British Antarctica Survey. He is using it. So another one is just I want to explore that. If you see, this is kind of analytical things. We can do that. Those who want to know the pattern, how it is exist, all the things. If you allow me, just I will walk through it, how it happens. Just I can. If you look at here, suppose you want to see the chart. Now I can go and I can select the particular duration here. Then I can submit it. This is online kind of a plot can be done. Any user can visualize it. Suppose I select here only. I remove wind speed, air pressure, and relative humidity. I'll be getting like this. So this is the temperature I'm getting it. Suppose I want to know only temperature, I can check it out. Suppose I want to see only wind speed, I can check it out. I want to see that only air pressure, I can check it out. Suppose I can skip here. I want to have only relative humidity, I can check it out. Now I want to see only temperature. So this is kind of, those who are not having bare minimum computing facility, they can access our portal, they can go through it, and further enhancement of their own research programs. They can access the data, they can request us, we will share the data. they can do whatever they wanted, and they can carry on their research work. So this is kind of monthly average for the year, whatever the year I have chosen from 2015 to 2020. So this is the monthly average. If you look at the pattern, also similar. This kind of things is available with the present meteorological data portal. So here we are provided 24 hours data. I mean, whatever the variation changes are happening, the last 24 hours data we are displaying it here. So this is, I mean, particularly this portal is developed using Django, Python Django framework, completely open source. We used, Python Django as an application server, PostgreSQL as a database server, and other libraries like pandas and other things. What are the libraries are available with Python? We have used it very extensively. The portal has been developed using completely open source. This is it is already migrated with my National Polar Data Center. So this is, this is separate portal. We have integrated with our National Polar Data Center also. So this is just, what I'm trying to do that, we are having collaboration with Indian Institute of Technology in Mandi and National Institute of Technology in Goa. We have some kind of collaborative research work. We are trying to predict whether can we use machine learning techniques for predicting a forecasting. Like, say as of now, we know that if you're looking at the weather prediction, we are using completely depending on numerical weather prediction methods. Can we use machine learning techniques for weather forecasting? If it is possible, how extent we can do that? So that is what we made attempt to do some kind of things. At the same time, we want to do for blizzard prediction also. It happens in Antarctica. Just we want to know that, yes, how the blizzard can be predicted, which can be informed our own station people, so that for their logistic and the scientific operation could be performed. They can avoid, suppose blizzard is going to happen, they can see that, yes, it will be alerted kind of things. So this kind of approach we started, and proof of concept has been done from our side. We look at that, we have historical data and data processing, current observation. We are going to use time series analysis. We are trying to find out the weather patterns and training the machine learning model or deep learning model. So whatever the model trains, based on the train, it predicts, then we are getting the either blizzard or weather forecasting pattern, we can easily find it out. So some of the patterns we used here, long short-term memory, that is called LSTM model. There are many models are available, but right now we are concentrating on the LSTM model, which gives predict good results when with whatever the sample data we have trained it. So now next attempt is we are going to go for deep learning kind of things like RNN, CNN, and we want to enlarge it. If it is trained, we are see that if it is perfectly all right, then we will moving into next stage. We will go into larger scale, how the machine learning techniques could be used for prediction of weather forecasting, whether it is short range or medium or long range, how it can be done. That is what we are aiming to do that. There are some sample graphs which we predicted. We trained for 2016, 2019, and we trained, the prediction happens for 7 months. So it is, if you're looking at the graph, it is somewhat better. So the next graph also we are taken for 8 months. So, if you look at, this, whatever we have done proof of concept, it seems to be good. So we want to go for proper machine learning techniques for predicting the weather forecasting. So that is what we are trying to do that. So this is what I want to have a discussion with you today. So any question, I can answer it.
All right, thank you very much, Mr. Sami. So please make sure that you start writing those questions. A lot of good material there. I do see that there is a question for you already. The first question is there any other place where Bharati's data is completely yet to be decrypted?
Sorry, I couldn't get the question. Can you repeat it?
Yeah, it's. I hope that I'm interpreting this right. Is there any other place where Bharati's data is completely yet to be decrypted, or it might also be is complete but yet to be decrypted.
Yeah, in our data portal itself, it is available. Data.ncp or .res.in itself, whatever the data is collected from our own Indian station, the data is available.
Okay, so it
Yeah.
sounds like it is available then.
Yeah.
Okay, great. Any other questions coming through? Just keep them coming.
Yeah.
No, looks like people liked it. So what we'll probably do at this point, those are our first three speakers, and we've got three left. We'll take a little bit of a break now, just give people time to either grab a cup of tea or use the restroom. I believe that it's a 10-minute break, so if people could come back in about 10 minutes time, then we will get started again. Okay?
Yeah. Okay.
Thank you, everybody, and stay tuned. We'll be back in 10 minutes.
Yeah.
All right. Okay, I think that we are back. Thank you very much, everyone, again. We are resuming the second half of our session, Improving the Fairness of Antarctic Data, Strategies, Tools, and Future Directions. Again, I'm Dr. Jonathan Kuhl, and I am the chair of SCADM, the Standing Committee on Antarctic Data Management. And we're talking about ways of trying to make data more findable, accessible, interoperable, and reusable. And I think I now know how radio hosts must feel when they're talking into the microphone. Anyways, we'll get started with the next three members of our panel. The first one is Pip Britcher. She comes to us from the Southern Ocean Observing System. And she's going to talk to us and tell us that data can't be fair if you can't find it. So we'll turn it over to Pip. Thank you very much.
Hi there. I'm hoping you can all hear me loud and clear. Thanks so much for that, Jonathan. As Jonathan said, I am Pip Britcher. I'm from the Southern Ocean Observing System. And I'm presenting today on behalf of Taco de Brown, who's here with us, and Amos Hayes and the rest of the Polder Working Group. And the question we've been asking in the Polder Group, which I'll talk more about in a moment, is can we really link all of the data repositories into a single search tool? So before I start, I want to talk a little bit about the FAIR principles, because I'm quite delighted to see we have a whole bunch of people in the audience today who aren't data managers and probably aren't terribly far buried in the FAIR data community. When the acronym was coined in 2016, it was predominantly describing machine discoverability and machine reusing of data, directed by humans, but really very much about getting the machines to talk to each other. And it's become more and more, as the acronym has been adopted more broadly, we're talking about it as humans being able to find and access and reuse data directly. So there's kind of a broad sense and there's a really strict sense. And I'm talking more in the broad sense today about making sure that everybody can find the data they need. And the question we really formed to answer is, why is the right data so cussedly hard to find? I'll explain that I have a PhD in terrestrial ecology and I'm very much a poacher turned gamekeeper when it comes to data management. I have sworn at people asking me to fill in detailed metadata records. I have gone hunting for things and got lost. And I think this is really why it's so hard. The font on this is way too small to read. This is a list of all the metadata catalogues and data portals that we discovered that host significant amounts of polar data that's relevant to our community. There's 80 of them across the two poles. There's about 50 or so in the southern hemisphere that carry Southern Ocean and Antarctic data. And that's a kind of huge amount of searching to be done. I don't think I know a single scientist who would go and search each of those catalogues one by one to find everything that might be relevant to them. If you know that you're looking for data that the Australians collected, then you go to the Australian Antarctic Data Centre. If you know that you're looking for Argo floats, then you're going to go to one of the Argo data repositories. But most stuff is a bit scattered. And these, we've highlighted some of the global data repositories that have large amounts of polar data in them, but we certainly haven't caught them all. There's a lot more out there. And there's a reason for this. And the reason is buried in 30 odd years of data management practice. When there was funding to start institutional level and national level data management, the first priority was to build a container to hold all of the data, to document it and make sure that if you went searching within that container you could find it all. And that's a huge and immense task, and SCADM in particular have done a huge job in terms of making sure that those data sets are preserved, they are curated, they are documented, and they are discoverable as long as you go to the right places. And increasingly the rest of the world is catching up with the way the Antarctic science programs have really got on board with sharing and making their data discoverable. The task for those of us in the background as data managers is to try and link all those together and to find a way to connect them up. And part of the problem is that because these solutions were local, they were local to particular scientific communities or to geographic regions, everybody created their own standard, or they took a standard and adapted it to their specific needs, and you can't easily just shunt all the data together. I stole this cartoon as a great lover of XKCD. Anton van der Putte, who has a slide presentation up as part of the main conference, showed me this the other day, and I was like, yes, this describes the problem exactly. There are 14 competing metadata standards. That's ridiculous. Let's come up with one that covers everything. And 5 minutes later, then you've got 15 competing standards. So I think anyone who's ever tried to standardize any data or metadata has probably hit that exact problem. And the question we're asking is, maybe there's a shortcut. Maybe we can come up with one standard at least for discovery level metadata. And the way we're thinking of getting to that is a thing called schema.org. And if you've ever booked a holiday or bought shoes online, then you have used schema.org. It's a little bit of structured text that goes in the header file of a page on the internet. And it means that everyone who's using it, you know, if we're describing a pair of shoes, we know what shoes are, we know what size regime we're using. We're using European sizes or American sizes. We know what the price is, and we know what currency that price is being applied in. So all those sorts of bits of information are structured up there, and then you can search across lots and lots of websites simultaneously. And so data managers kind of got in on this action, and sick of being asked, can't I just Google it? Turns out now you actually can just Google it, because enough of us have implemented schema.org for data. So if you are not aware of this tool yet, I suggest you go and have a play. Datasetsearch.research.google.com. It's a toy that Google put out about 2 years ago. They have 2 people. It's their Friday afternoon project, and they'll keep it up and running. And you can type in whatever text you like. And I did a very obvious search for penguin data today. We found 100+ data sets. So you want to be a little more specific in how you're going to search within Google. And it works. It's pulling in data from the GCMD, so the Antarctic Master Directory, and it's pulling in data directly from several of the National Antarctic programs. But it's pretty basic. You can't filter by time or by space. You can do just basic text searching. So you're going to have to be pretty selective with the text you put in there to find the exact data set you need. However, because Google picked up this schema.org approach to managing data, it suddenly put a whole lot of weight into one corner of the room, and a lot of data centers are now saying, well, if Google are doing it, and our bosses are really pleased that they can now Google for our data, we'll implement this. And the nice thing that's really different about schema.org compared with previously, there's been dozens of standard ways to write metadata, is that we're not asking anyone to replace what they're already doing. We're not asking anyone to stop what they've done and jump onto our new one standard to rule them all. This is a small add-on that you can do as a nice to have on top of your main structured metadata. And it's just for pointing people in the right direction. So there's a group in the US, the Earth Science Information Partners, who have a Science on Schema.org group. And their task is to try and figure out how to do this right and do it once. The one thing we're all really, really carefully trying to avoid doing is repeating what we did with some of the older metadata standards that were designed to be one standard to rule them all. And it turned out everyone implemented it differently. And what somebody is calling a title is what somebody else is calling a description. And they never quite match up properly. So globally, Earth Science Information Partners have been building search tools based on schema.org that will allow you to search by time and by space, as well as by keywords, and trying to make sure everyone documents their data in the same way. And they're aggregating, they're working through GitHub and anyone in the community is welcome to just jump on in and start making pull requests and suggesting changes, because the group that is involved in ECIP are mostly developers and data managers. There's not a lot of people who can talk about how this will actually get used and what the actual data types will be. And because it's the Earth Science Information Partners who started this, there's a real bias in the kinds of data that have previously been described. So we, in the polar community, and by that I mean SCADA, the Standing Committee on Antarctic Data Management, which is SCAR's data body, of which Taco and I are both members. SOOS, the Southern Ocean Observing System, where I am the data officer and Taco is on my data committee, and the Arctic Data Committee, which Amos Hayes, our co-author, is part of that. So those three committees got together and said, we need to make sure this works for the polar regions. People in other areas don't really describe ice that well. They don't, particularly for our Arctic colleagues, there's concerns that that if you don't have specialist input, we're not going to cover Indigenous knowledge and traditional knowledge in any effective and respectful way. And so we put together a group, the Polar Data Discovery Enhancement Research Group, or POLDA, which is a Dutch word, as well as meaning the wall that keeps the water back. It's a way of working together to come up with a solution that works for everybody. And that group has been working for a couple of years now. The first thing we did was we went, if we want to federate search, if we want to search across all of these catalogues so as to save scientists a whole lot of pain, then we need to figure out what system we're going to use, and we have settled on schema.org, particularly once Google jumped in on that scene. And we're now working through the nitty-gritty of exactly how to do that consistently across the polar communities. We're agreeing on the vocabularies that we use. We're agreeing on which fields are mandatory. We're agreeing on how to make sure that we can respectfully cover humanities data, as well as just what the people within schema.org thought and what people within Earth Science Information Partners were thinking of as a data set, which is pretty much a grid of structured numbers. We want to make sure we've got space for all kinds of data to be well represented here. And really importantly, we're making sure we reach out to people in other geographic regions so we don't make yet another data silo that we're going to have to escape from in another 10 years. So what I would like you all to do now is to keep an eye out. New search tools are coming, particularly out of the US. We will be writing a best practice guide for how the data centers should make sure they implement schema.org so that your data is easily findable when anyone, anywhere in the world jumps on and does a search. And we're doing outreach to partners in related disciplines and other geographic regions. And hopefully, with all of these little pieces of work being done by lots of partners all over the world in the next couple of years, it might not be just Google for your data, but there should be one tool to rule them all. So thank you all very much. For those of you who are interested in how this works and wanting to make it better, we're meeting up every couple of months at the moment through Polar Data Hacks, and we'd love it if you joined us. You can send me an email at what's probably the shortest unique email address in the world, or jump on the SOOS website where we've got a whole bunch of details about what Polar are up to. Thank you all.
All right, thank you very much, Pip. That's great information on schema.org and federated search. And I can also say that I'm a bit of a convert, that Pip told me about the benefits of schema.org. We brought it to the Australian Antarctic Data Center, and indeed, it has helped the discoverability of our data. So I'm going to read off some questions for you, Pip. The first one is that we've got, and yes, please type in the different questions. So will the schema.org automatically include all the data, or just if it is open access?
Schema.org will find any metadata record that has been written. So it's working through the metadata text rather than looking at data in particular. So if you have written a metadata record but the data themselves are embargoed, schema.org will find it and link it. And just push people through to the data center's website that was sharing your data in the first place. And then if someone wants to ask you for access to it, then they can, and you can say yay or nay. We're very aware, and particularly because we're working with our Arctic colleagues, that there are all sorts of data sets that shouldn't be made public or shouldn't be made public immediately right now. And we want to make sure that we treat those respectfully, whilst we're all data managers, and what we really care about is making data as freely shareable and reusable as we possibly can. We do that within ethical constraints. By the way, I'm going to apologise in advance. It's a bit stormy here and I'm sitting under a tin roof. So if I get drowned out by rain or thunder, I'll apologise in advance.
No, you're doing just fine, Pip. So the next question that we've got is, when are you planning on rolling out schema.org, and do you have a timescale already?
Well, lots of our data centres already have. So like Jonathan said, the Australian Antarctic Data Centre have, the British Antarctic Survey have, NEOS, the Netherlands Institute for Sea Research, have. The GCMD, which is the American NASA's organisation that underpins the Antarctic Master Directory, they've implemented it. So schema.org exists, people are using it. The challenge for us, ultimately, we would like to develop a polar specific search tool, and the search tools that can do time, space and keyword all at the same time are still being built as a largely volunteer effort. So I don't want to be promising fission sort of nuclear fission seems to be always 10 years down the track. I'm hoping it's a lot less than that. I'm hoping it's in the next year or two, but this is very much an open source volunteer led effort, and it'll happen when it happens. But the immediate benefits are rolling through, particularly for people who are using things like Google Dataset Search.
Well, that leads quite nicely into a next question, and I think you'll like this one. Do you take volunteers?
I love volunteers. Everything we do is entirely done by people working off the side of their desks. So please, data@seuss.aq. Flick me an email and we'll link you into the whole group, and we'd love to have you on board.
And I have just added that to the chat. So anybody looking to get in touch, I'm absolutely certain that Pip would love to hear from you. Okay, it looks like we've cleared our current batch of questions. Thank you very much, Pip. So I am going to move on to the next speaker. It is Anton van de Putte, and he's going to be talking to us about biodiversity data. Do we have you, Anton? Anton?
I hope so. Yes. Do you hear me?
Yes, we can hear you just fine. Thank you, and over to you.
Okay, you should see my presentation now.
All good.
Oh, good. Okay. So I'm going to talk about making your Antarctic biodiversity data fair. I would like to start actually with a short story as to why I care about fair and open data. So when I was much younger, had much more hair on my head, back in 2006, as a young PhD student, I embarked on a 3-month voyage on the wonderful Aurora Australis from Australia. And 3 months later, I came back with about 427 fish samples for my PhD to work on. Most of them were not, as you can see from that picture, not that very big. And then I started analyzing the data, and then I came at a point where I realized there was a similar expedition in an area next to it that had the same sampling protocol and caught similar data. And it would be very useful to combine those two data sets to get more knowledge of what was happening as a driver in an ecosystem. And what happened is I spent 6 months trying to find the right data that I needed. I contacted authors, they forwarded me to somebody else, everybody giving me the data that was not suitable for my needs. And the frustration that I had in not being able to combine that information and get insights of what I knew I could get, sort of instilled an interest in me to make sure that there's access to open data and access to good open data for biological research. So now I work for the Royal Belgian Institute for Natural Sciences. I manage the SCAR Antarctic Biodiversity Portal there. And together with my two colleagues, Ming and Maxime, we support standardizing biological data. We support the publishing of that data. But we also, together with groups like the Expert Group on Antarctic Biodiversity Informatics, support the development of tools for analyzing biological data. We also act as the regional nodes for OBIS and GBIF. These are the two largest biodiversity information facilities in the world. So OBIS is Ocean Biodiversity Information System, and GBIF is Global Biodiversity Information Facility. Coming in the last of a series of talks, you realize that people sometimes already say the things that you want to say. So people have already defined what the FAIR principles are. I'm going to look at what the FAIR principles are not. So the FAIR principles are not a standard. So it's a set of guidelines. It's not a standard that you have to follow, but it will guide you to managing data in a better way. FAIR is also not equal to open or free. So open data is defined as data that can be used, reused, and redistributed freely by any person, and that are the subject at most of the requirement of attribution and to be shared in the same manner in which they appear. And actually, FAIR data is much more guided towards a principle that is open as possible and as close as necessary. And that has to do with the focus which is on the metadata. FAIR data require that the metadata are findable, but it does not mean that the data behind it has to be freely or openly accessible. So not all open data is FAIR because it might not be easily findable, or it might not be reusable, or not all FAIR data is necessarily open. And finally, having your data being fair is still no guarantee for success for open science. There's still a lot of hurdles that we need to overcome. So the FAIR principles, as Pip said, they're actually geared in their start towards machine readability. So it's about making machines communicate better with each other. But actually an environment where we as researchers are more and more using analytical workflows and programming to bring together data and to analyze that data, it becomes more and more important that we apply these FAIR principles not only to these metadata, but I think also to the way that we work ourselves. In essence, if you make sure that your data is adhering to the FAIR principles, it means that people can find, access, interpret, and reuse your data. And it also means, by definition, that the future you that might not have the memories or the active engagement with the data that you're working with right now, and your future you might not have that recollection. So if your data is fair for anybody, they'll also be fair for yourself, and it means that you can do your research on your own data in a much more efficient way. And so the research and data life cycle, often it's by scientists considered to be something different, but it's something that's really intertwined. So you start with a scientific question, you write a proposal, you do your research, and during that research, what you do is you collect data, you start processing and cleaning that data, and then you do an analysis, and then it's preserving that data either for future research or for your own publication. And so actually the research component of your research cycle is actually working with data. So if we keep in mind that we use these FAIR principles again throughout our research life cycle, that will help you in the end with your research. So some general tips is that before you start a project, you should make a plan for the data. What data you're going to collect, in what format should you use them, what are the standards. Throughout your research, you should collect detailed descriptive information on the data. Where you can, use standards and formats that are common to your discipline. store the data in a trusted and sustainable repository or data center. All of this ensures that your data is easy to interpret and stay safe. This is also part of the FAIR principles. See to it that the data gets persistent identifiers, DOIs. This means if your data has a DOI, it's very easy for people to cite that data. So it increases the recognition for what you're doing. Apply suitable usage license. Also provide the end users with information how it's intended to use. A very common argument is that people don't want to make data openly available is people are not using my data in the right way. Well, if that's an issue, it's something that you can address by telling people what the right way to use the data is. Again, according to the FAIR principles, make your data as open as possible and as closed as necessary. If there's reasons to not share all of the data or to anonymize it or make it less precise, yes, you might have to do that, and that's fine. Ensure that the metadata remain available even if the data cannot be accessed anymore, so that at least a trace of that can be found in the future. And fairness needs to be applied where it makes sense. So all of these principles can be difficult to remember, and it might be useful to assess how fairness the data is at the end. Again, it's not a standard, but by assessing fairness, we can sort of get a metric for ourselves of how well we're doing with the data that we have. But when you think about that, assessing fairness, keep in mind that reaching a 100% fair bar is often unrealistic, and you should be happy with fair enough. And of course, the level of fairness, because fairness is mostly about the metadata, it says nothing in essence about the quality or fitness for use of the data itself. So here, I'll share this presentation on the portal as well. These are a number of online tools. These are basically questions you have to go through that will allow you to assess how fair your data are. And they're very simple questionnaires, and they can be quite useful. So what I thought to do in this presentation is to look at how fair your data are if you would publish them through OBIS or GBIF or in a data portal that is linked to OBIS and GBIF. So for instance, data that is published in the Australian Antarctic Data Center is automatically linked with OBIS and GBIF. So there are connections there that make the data very discoverable. So we, with the SCAR Antarctic Biodiversity Portal, if you don't have a contact for that, we can help you with doing that. The type of data that is published in that way can be very broadly. It can be just the metadata. So this would be completely FAIR compliant. Then you have checklist of species, where these species might occur. Then you have occurrence data, which is telling you where an individual organism is found. And then there's event data, which is a new format, which can be quite interesting to use as well. So let's go through this type of questionnaire. Findable. So if you publish your data through OBIS or GBIF, this data set will get a DOI. So it means that the data set has an identifier, a persistent identifier assigned. So that's a green tick. Is the data set identifier included in all of the metadata records files describing the data? Mostly. In not all of the files that you find in the format, you will find the reference to the metadata identifier, but there is
I think, Anton, if you may want to check your microphone, but we'll try and get Anton back as soon as we can. Anton, any luck with your microphone? We're kind of close to the end, but we'll see what we can get. Apologies, we're just having a couple of technical difficulties, but we'll see if we can get Anton back. What I can do in the meantime, just to fill a little bit of the space, we do have a question from Kat Ritz. She's saying that she'd like to request that we collect all the interesting websites mentioned and put them in an easy to find place. So we can absolutely try to do that. We've got the collection through this presentation, but yeah, we'll see what we can do to collect those all together in one spot. Let's see. Another question. I can probably take this one. What is the relationship between the various databases and DOI? DOI is a digital object identifier, and it's a persistent link that can be used to identify data objects, and a database can be one of them. So it provides a nice way of citing things, and also knowing that what you're linking to should be sort of the definitive version of that thing. So DOIs are extremely handy for us in terms of being able to really definitively define what we're talking about in terms of what the data is for citation. And it's incredibly useful for actually tracking metrics and citations the way that happens with a lot of scholarly research. It's useful for us to know whether a data set has been cited 30, 50, 100, 1,000 times, because it helps us to make sure that our data is valuable and helps us to demonstrate that it is worth getting funding for. Last question I'll try and take, and if we don't, then we'll probably just try and move on as best as we can. Is Antarctic data fair as other data, the Arctic? How does the management of Antarctic data compare with other research areas? It's a little bit tricky for me, but I have been in a couple of other disciplines as well, in the marine biology space, and some of the other areas. And I would say we do have a little way to go, but in my personal experience, I do find that Antarctic data does tend to be a little bit more fair. It does tend to be a little bit more collaborative, especially because of the international nature of Antarctic information in general. It really is a global effort, requiring countries to come together, in particular under the Antarctic Treaty. So I find that the Antarctic community, again, in my personal experience, it does lend itself to more fair data. The question about any free DOI providers. Yeah, I usually there are DOI publishers. I'm not sure about the free aspect of it. Not in my experience. That doesn't mean that there aren't any. Usually what you would have to do is you would work with a trusted repository who have that as part of their system. But my answer to free DOI providers, I really don't know. I haven't encountered any personally.
Hi, Jonathan. It's
Yep.
Pip. Can I butt in?
Yeah, please do.
Awesome, thank you. Joanna Grabau from SCAR has just mentioned Zenodo. So if you're using Zenodo for sharing anything, they will mint you a DOI.
Oh, okay.
As a general principle, if you're cleaning up and sharing data, I would always be suggesting that people go through a trusted data repository, who almost all of them now are minting DOIs, and can make sure that your data are as findable as possible. Whereas Zenodo is a little bit of a generalist. You can dump it, and then no one's ever going to quite look after it and love it into the future.
Well, and that's the other aspect, is that you really, if it's going into a DOI, you want it to be persistent, taken care for over the really long term. And the best way to do that is to put it in a repository who have that mandate to take care of things really, really over the long term. Okay. All right, so we're just going to, we're probably going to move on. Apologies for losing Anton. Not quite sure what happened, but we'll try to make up for it with our last speaker. who is Frank Nietzsche. He comes to us from Lamont Doherty Earth Observatory, and he's going to be talking to us about support of Antarctic data lifecycle management with the USAP DC. So Frank, over to you, and we're looking forward to your presentation.
Thank you, Jonathan. And I'm gonna, let's see, share my screen. All right, can you see my presentation?
Yes, I can see it.
Okay, great. So my name is Frank Nietzsche. I'm a research scientist and data creator at the US Antarctic Program Data Center that we're hosting at Lamont Doherty Earth Observatory. And I work there with my colleagues, Suzanne Cabot, Neville Shane, and Kirsty Tinto. And today I want to present some tools that we're using at USAP DC to basically support different stages of the data research life cycle. And Anton's presentation was a really good segue to what I'm going to talk about. To give you a little background about the situation in the US, so in contrast to many other countries, we do not have a national Antarctic or polar data repository. Instead, I think the main way how data are handled in the US is that we have discipline-specific repositories. So there is BICO-DEMO for biological chemical oceanography, or NAFCO for GPS data, or GeneBank for genetic information. And these repositories are not Antarctic specific, but they are basically, discipline specific, regardless where the data are from. And that works very well because it's discipline specific repositories that can provide tools and curation and maybe metadata schema very specific for these data types that they're very familiar with. But there's also some challenges that are linked to having this discipline-specific repositories, because sometimes there might be data generated that don't really fit into any of these specific repositories. The question becomes then where to put those data. And then another issue sometimes is if you have a project with different types of data, they might end up with having like data sets in different repositories, and it's really difficult to really find or get an overview of where all the different data are. And this is where we come in as a US Antarctic Program Data Center. So we are basically funded by the US National Science Foundation, and our mission is to support investigators of the US Antarctic Program. And we have two main functions. So one is actually to be a kind of run a project catalog or registry where we basically have to keep track of the different connections of Antarctic data that are the different discipline-specific repositories, and it makes this available in one place for easier for people to find. And the other function is actually to act as a data repository. So we are mainly hosting glaciology data that are collected or generated by the US, by the NSF-funded projects, but we also, kind of the repository for any other kind of data that are not really fit in any of the discipline repository, with the goal behind that, that all data that are generated through the Antarctic program, US Antarctic program, are have a place where they can go, even if there's not even a discipline-specific repository. And Anton very nicely explains the research and data life cycle, so you don't have to go through the slides in detail. Here I'm kind of mixed up the two separate cycles that Anton had, because as he mentioned already, there's a project or research life cycle is actually quite strongly tied to the data life cycle. So in this case, you know, you often start with looking for data, trying to reuse it as a basis for a new research idea. We write a proposal. And if this proposal gets funded, we start a project. And in this project, we generate new data. We do some analysis on this data and maybe end up with final data products, and then, you know, want to make this data available and use this data in publications and present it this way. And then this becomes, again, the basis for new data discovery. Maybe they get reused, and, you know, people come up with new ideas based on the old data, writing a new proposal, and so on. The cycle moves. And so we're trying to help investigators along the different stages of this proposal, of this project or data life cycle. And this is now, you know, instead of a circle like lined up, different stages that we support investigators at. So at the beginning, at the proposal stage, we're trying to have some tools to help people to find data and to get to the data and use them. And I'm going to talk about this in a little more. We don't have in the US, you have to submit now a data management plan, which actually helps people while creating a proposal to think about what they're going to do with the data. We don't have a tool ourselves, but some other colleagues at Lamont, together with other universities, are heavily involved in a tool it's called EasyDMP that helps investigators create this data management plans for their proposals. And once a proposal gets funded, there's an award, we then have a possibility for the investigator to actually register their awarded project at our catalog. And then as it moves on and generate data, process data, and have final products, those data products then get either archived in one of those disciplinary repositories, or they can archive those data at our UCDC repository. And then we're gonna issue a DOI to this data integrated with our catalog and help to make it a findable. The same when then external repository, then it's up to the investigators to tell us where they are in most cases, and we will integrate it in the catalog and make it findable. And finally, if the data are then, you know, can be used in the publication, people, the authors can use the DOIs for the data sets to cite the data, but we also have ways that we actually can link these publications back to the actual data or to the projects, so that, you know, people who look at the data find also related publications with them. And I'm gonna demonstrate the different ways, different tools that we have for this now to start off. So the first thing an investigator would do would basically, you know, register their project. And so on our webpage, you can go to contribute and then go to register a project, which will open a web form that we try to keep it really easy for investigators to make the information about the project and data sets available. So we have a relatively simple web form where we collect information about the award, that the investigators or other scientists involved in it. They can enter information about expeditions or deployments, if it's a field-based project, and provide information like where, you know, data sets might be archived, or once they have publications, they can add those. And because from the beginning of the project, a lot of this information about deployment, where data sets are hosted and publication will not be available. So this project page basically can be updated throughout the life of the project. If we have this information, we give you an example what kind of information we have and how we present it. So we have like this project pages. We have like basic information, title, start, end date, a description of the project, and what kind of who are the people involved, investigators, co-investigators, researchers can be listed there. We have links to the actual NSF awards. We have links to the, if there's any entries exist, to the Antarctic Master Directory. Then the key part is the links to the data sets themselves, and then any publications that result as part of this project can be listed as well. And as I said, so you can see it in the top right corner, there's like an edit button, so the users can go in and update the information. And all these updates on the original submission are being curated by me and another of our data managers, basically. But the idea is that can be updated as more and more data become available. And even if they don't provide the data to USFDC as a repository, but another discipline repositories, we can collect all this information in one place, and then it's very easy to find all the data related to a certain project. The second step is once you have data generated, you can submit it to another repository, or you can submit it with the USFDC. So one way, again, you go to the webpage, contribute, deposit data set. We have a web form. Again, where we collect basic metadata, but we also collect as much information as we can about data acquisition, processing steps, how the data have been built, trying to get as much provenance information about the data, but we heavily rely on the investigators to provide this in a useful format. If there's already related publications, we collect those, and then there's ways for the investigators to upload the data. And once we have this information, we actually will associate the DOI. This came up in the questions before. So we're using a service like a DataSite, create a DOI for all our data sets. We also will link any data sets contributed to us to project pages, and then expose this to the various different search engines to make it more findable. An example again for what's a data set, what information you find if you look at it. So we have a data DOI here, title, we have a provider citation if somebody would, a suggestion how to cite the data set, a link to the Antarctic metadata directory record. We have some basic metadata here, award number, a link to a project page. You can find other data sets that are created about the project, publication, with a link, and then we have a README file that will contain all the information about processing, data acquisition, and other more detailed metadata information. Then you actually can download the data files directly from here. Good. So for people who, the one thing I want to mention, so was discussed that we really support publication of data sets. That's a big plus. Now we have the option, like many other data repositories, how to create DOIs for data set records. We're using DataSite, and that's the benefits of DOIs really, that it makes it much easier to get your data cited. Excuse me. In publications. We also implemented the opposite way, so users can add, as you've seen, publication to dataset on project pages. Having this there will probably help people who reuse your data to, maybe look up more detailed information in the paper, or eventually also cite the paper. And we also, to make it a little easier, we now started an experiment to automatically at least populate the project pages with references that we are finding based on the award information through Crossref. To make the data more findable, so one way we're doing this is people can browse on our web page. Again, if you come to userdata.org, you can go to search, and we have a general search interface that searches both the project catalog and the data set that we have in our system. You have the option to search by free text, looking through keywords and awards person or to specific, you can also search by specific programs like the West Atlantic Ice Sheet Core. That's larger projects that have multiple awards or sub-project linked to that. So you can search as data, and our webpage makes them findable, but as we've seen before, that might not be the only way, because not everybody wants to go to all the different repositories to look for data. So we're working with other catalogs to expose information. So we provide entries of our data to the Antarctic Master Directory. People can search there for data. We expose the data set also to Data One, that's mostly US, like data hall that links to various repositories, and also following like in Pip's talk, also we also include schema.org information, so it's searchable by Google data search, and hopefully once we get the folder data search interface going, it will be findable to that as well. So the goal overall is like to make it discoverable and encourage reuse by putting the data in as many possible places as possible. Another thing that we also now started implementing more recently is that we have started offering now API connections. So it's basically if you're it allows machine programmatically to search our database, for example, looking for certain awards, what data sets or projects we have linked to certain awards, what are the data sets we have, and retrieve basically using machine tools some metadata information from our data sets, getting the information of which projects or data sets might be linked to certain persons, or what are the data sets that we have stored for various projects. But this is something we're just starting to build up. But again, that will help if more and more repositories have those services. It will help linking, between different repositories as well. Since the session itself is mostly about the FAIR principles, not so much about the tool. So with the tools that we have in place now, I think we have good handle to make our data findable in various ways. I think that's went pretty well accessible. It's something we also aim to do good. We have like protocols and a license our data for that. So these are like easy to do for a domain-wide repository like we are, that's not really discipline specific. I think we find it more harder to implement the machine readable harmonized standards that might lead to better interoperability of the data set, because a lot, as also been mentioned before, there are so many different discipline specific standards, and since we have biological, marine, oceanography, and sometimes even social science data, that's really difficult to implement, like all the different standards of, since there's not really one main standard. And we do try to provide some information about reusable, like a lot of information, like how the data were collected and processed, to make reuse of the data more easier and possible. But again, there's not, we don't really know all the different standards. What's useful for one discipline might not be useful for another discipline. So this causes a few issues for our repository. In summary, so we basically providing a lot of, or several tools to help, the project lifecycle, different stages. This includes linking the data and publications to DOIs, data side cross-ref. And we're trying to make the data findable through multiple pathways, including, having a search tool ourselves, but also to integrate it with other bigger catalogs on using schema.org. or offering API services. And as I said, so findability is something we, I think, have a good handle on, but I think reusability and especially interoperability is still a challenge, especially for, you know, a non-discipline specific repository that we are. And that is, and I thank you very much. And if you have any, you know, questions, please email either us in general at info@usabc.org or email me directly. And please check out the website if you can.
All right, thank you very much, Frank. Any questions, please feel free to submit them online and we'll try and get them to Frank. I should also let you guys know that Anton has rejoined us. We're going to give him the opportunity afterwards to finish up his slides. But yeah, in the meantime, any questions for Frank? Looks like you've covered it all pretty well. Okay. All right, well, we're going to say going once, going twice. All right, thanks, Frank. Much appreciated. That was great.
Good.
Okay, Anton, do we have you back with us?
I think so.
Okay, so we'll get back to Anton after a little bit of technical difficulty, but we're looking forward to hearing the end.
Okay, I think I was at assessing the findable component. So how is the data described with the metadata? So the Darwin Core archive uses the ecological metadata language standards, which is an XML format, which is a completely machine readable format. It's actually quite extensive. We have a tool in place that based on that ecological metadata language, you can actually almost automatically generate a data paper that's almost completely ready for submission. So that can be quite extensive. So it's quite good. GBIF and OBIS, both are big domain-specific repositories. And as what was mentioned by Pip and Frank, they actually provide schema.org as well. So if a data set is published through OBIS and GBIF, it's also findable with schema.org. How accessible is it? In OBIS and GBIF, you might need a login for a download. But once you have that, you can actually access the data completely publicly. It's actually available online without any special protocols or tools once the access has been approved. So there's API services and you can go through an online portal to find the data. And that's the same for our portal. At the SCAR biodiversity portal, you can also use these API services to get data. The metadata records, will they be available? What we actually see is that they do stay available for a very long time, but in some cases, if the data seems to be very inactive, they might choose to suspend that record. So that's not always the case, but that might change in the future. Interoperability, as Frank said, I think that's more of a domain where the responsibility of the data manager or the data provider, the researcher in this case, becomes more important. So is a file format where the data, what is the file format the data is available in? In case of Darwin Core, this is structured, open, and machine readable. So that's a big yes. Darwin Core does not has a couple of vocabularies that it enforces, but in general, it's fairly open and free for interpretation, which is an advantage, but it also can be a disadvantage. In the case of OBIS, they've decided to work with the vocabularies of the BODC, and they actually enforce a high level of using vocabularies and ontologies. How is the metadata linked to other data and metadata? That's also quite actively done. So then finally, the reusability. So OBIS and GBIF publish under a CC0 or a CC BY or a CC BY non-commercial use license. So these are the most open licenses that you can find. So it makes the data quite reusable. Provenance information, again, it's not necessarily provided by OBIS and GBIF directly, but you as a data provider can do that. So I think my conclusions are a bit similar to the ones that Frank provided, as that if you link to OBIS and GBIF, your findability and accessibility are actually taken care of on your behalf. And I think the interoperability and reusability are dependent on you and your data manager in following the data standards and making sure that the quality of the data that you provide is sufficiently high. So that is my presentation. If there's any more questions, I'm happy to answer them.
Great, thank you, Anton. I have to apologize. I poached most of your questions for you. You had quite a few, but if anybody has additional questions for Anton, now's the time to get them into the question box. I did get a couple of questions for you, Frank, that came on the tail. So are you still with us, Frank?
Yeah, I'm still here.
Okay, so we've got the first question that I got is, thank you, Frank. This is an excellent tool. Can you comment on the connection between the new USAP DC and the Wisconsin-Madison AMRC data center?
So we do not have the point that made a connection with a new data center yet. So there's a Wisconsin-Madison MRC. It's like the Meteorological Research Center. So it collects basically the data from the automatic weather stations. And so they have like a separate direct data stream at the moment. The data go to them. I'm guessing if we have like a project that's like funded, we probably would get them in our project directory for the individual award, but they're kind of a separate tool. It's like a separate data stream at the moment.
Okay, another question for you from an anonymous user. A question for Frank, really interesting. To get a sense of scale, do you have an estimate of how many data sets projects you have stored at the moment?
Yeah, so it's a good question. So the project pages is something we just started last year, and we're trying to go back and get some legacy projects. So at the moment, I think, well, there's a data repository itself. At the moment, we have a little, like 650 data sets at USAPC directly stored. But through the project pages, we have like over like 3,000 or 3,200 something data sets. You know, that where we have links to other data sets at other discipline repositories, including ourselves. And at the moment, we have like around 800 projects on our project page, but we don't have all the past, like all the awards projects. We're trying to fill this up with time.
Okay, great. Anton, this one might be a good question for you, if you want. The question is does the SCAR Antarctic Master Directory serve as an umbrella for all these various repositories, or how can the role of the SCAR Antarctic Master Directory can be defined? You want to take that, Anton?
Yes, happy to do that. Well, yes, I think that's a correct assessment. So with all of the National Antarctic Data Centers, what we try as much as possible is to get the data that we have in our repositories into the Antarctic Master Directory. And I think the use of schema.org fits into that. It's if we all can use that standard, it can make all of those data sets much more discoverable through the AMD.
Okay, great, thank you. And one last question, we've got, what will the actions to help the future SRPs to be as fair as possible? I'm not sure what an SRP is.
Well, so for the biological data, I've been engaging quite actively with the biological SRPs, scientific research programs.
Oh, yeah.
That is. So with the biological one, I've been engaging with the proponents for that, and I think it would be very good if all SRP leaders try to actively engage with SCADM. So we have experts within SCADM in various domains. So there's, if the person you're contacting initially is not an expert in your domain, we can point you to one within the SCADM group. But so for biological data, it's an ongoing effort, and we plan to keep a close eye on that.
Okay, great. Pip, did you have anything that you wanted to weigh in on that?
I might weigh in on both of those if I might.
Sure.
So just for clarity for some of the non-data people here, the Antarctic Master Directory is an umbrella search tool for the National Antarctic Data Centres. So those are the data centres associated with National Antarctic programs. And that's got pretty well all of that. There's a few who aren't submitting their metadata to the Antarctic Master Directory. What it doesn't do is pick up metadata from all of those other data repositories across the globe that happen to have Antarctic relevant data in them. So there's a subtle difference there. The AMD is an extraordinary thing. It's been around. It's doing what schema.org wants to do. It's been doing that for the Antarctic community now for 20 years. It's just that there's all these other communities that chose different standards who are really hard to integrate into the GCMD, so we're looking for something to pull them all together into a new, greater, more wonderful Antarctic Master Directory in the future. And then just on the SRPs, SUS is reaching out to all three of those in coming weeks to have a chat about how to integrate with the broader Southern Ocean Observing System, and we will most certainly be talking about fairness of data.
Thank you. So I think that takes care of the two questions that we have in there. Now's your chance. Any last questions, or is everybody all pumped up for fair data? I think that sounds like everybody is ready for fair data. So I would just say we've reached the end of our presentation, but this doesn't mean that it's the end of fair data. If anybody wants to get in touch with us, please check out the SCADM page. Feel free to email me, and you've also got the information hopefully in the chat and in the transcripts. But yeah, what we can do is from our presenters, if you do have your cameras, please turn them on so that we can take one last bow amongst us. But I also personally want to thank everybody for attending, and yeah, just really thank you for taking the time to be interested in fair data, to be interested in the work of SCADM, and working all together as a community to really try and progress Antarctic science, Antarctic research, Antarctic data. There wouldn't be much for us data managers to do if it weren't for the researchers working hard to give us something to take care of. So again, where we can, we'll just have everybody put on their cameras to the extent possible, and we'll wave and say, thank you very much, everybody. It's been a pleasure, and I hope that you got a lot out of it.
Thank you all.
Right.
Okay.
Thank you.
Thanks, everybody. Take care.
And have a great night, and we look forward to all the rest of the sessions.
Okay, bye.